Now let's look at dilution. Dilution is adding extra solvent to decrease the concentration of a solution. And I like to think of this in terms of Kool-Aid. When you make Kool-Aid, you can add a lot of water to make it dilute, or you can add a little bit of water to make it more concentrated. So in either case, the amount of solute, the Kool-Aid, is going to stay the same, but the concentration decreases as I add water. So to dilute anything, I'm going to add water to it. Here's our dilution formula. The concentration of our initial solution times our volume of that initial solution is equal to the concentration of the final solution times the volume of the final solution. Concentrations and the volumes can be any units as long as they're the same on both sides. So if I have a high concentration, I'm going to have a small volume, which will equal a low concentration times a high volume. All right, so let's look at this equation in terms of molarity. It's written M1V1, our initial molarity times our initial volume, is equal to our final molarity times our final volume. And I always have the more concentrated side on the left-hand side, because when we dilute, we're going to add water to the more concentrated molarity. So this will be my concentrated side, my high molarity, and a small amount of volume. I'm going to add water to this side to get a new volume, which will be larger than this volume, and my molarity will be smaller because my concentration will go down. So concentrated, dilute, small, large. And as in any equation, you can, however many variables you have, you can solve for any one of those variables if you're given the values of all the others. So I've rearranged this equation so you can see how you can solve for each variable. If you're solving for initial volume, this is the equation you use. Initial molarity, this is the equation you use. Final molarity or final volume. Now, I've used molarity here, but you really can, as this slide says, use any concentration unit. Volume can be any unit as long as it's the same on both sides. So let's look at this example. What volume of 12 molar potassium chloride is needed to make 5 liters of 1.5 molar KCl solution? So the first thing we want to do is we want to write out our equation. So the first thing after we write our equation is we want to go ahead and assign all of our values. I'm giving that I have 12 molar of potassium chloride, and I want a solution that is 1.5 molar. So this is my initial concentration, my high concentration, and over here is my diluted concentration, my lower concentration. And I have a volume of 5 liters. So the problem is asking for what volume of this molarity do I need to make this final solution. So if we look back at the equations that I've written out, we see that to solve for V1, that's going to be equal to M2V2 over M1. So M2 is 1.5, and in this case I'm just going to leave molarity as capital M, times V2, which is 5 liters, and then I'm going to divide that by M1, which is 12.0 molar. So I notice that my molar units cancel out. The units I'm left with are liters, and my calculator tells me 0.625 liters is what my V1 is. So what this means is to get my diluted solution, I would measure 0.625 liters, which is 625 milliliters, of my 12 molar KCl. So I can use a graduated cylinder to do that. And once I have that, I'm going to add enough water to this whoops, I'm running out of room here, to get 5 liters. So we would measure 625 milliliters of my 12 molar solution, a small volume of high concentration, and then I'm going to add water to it to dilute it to get my new concentration, my lower concentration of 1.5 molar, and a higher volume, 5 liters.